Welcome back everyone, Mr. Wooten here once again. Today we're going to be seeing a video on our next topic, which involves polynomial operations and in particular adding and subtracting polynomials. So we're going to build off of the ideas that you worked on in the last couple of days, taking like terms and combining them, but we're going to see those from a slightly bigger perspective, where we have one polynomial either added to a second polynomial or one polynomial subtracting a second polynomial. And we're going to talk about the similarities and the differences between those, and then how we can apply those in some contextual situations and some story problems. Okay? So good luck as you go through this video. So let's begin by looking at our topic for today, adding and subtracting polynomials. Once again, we're going to begin by looking at our key questions. First key question, how do we add polynomials? Then we're going to take a step back and see how we subtract them, the similarities and differences there. And then finally, we'll wrap up our video by looking at how to apply this in some sort of a context or a situation where maybe we even need to draw a picture to help us think through what this looks like and how we can apply this topic of adding and subtracting polynomials. So here we go. We're going to begin with this first problem. Adding polynomials, we can see that we have two polynomials here. I have a quadratic because it's degree 2 in the first polynomial, and another quadratic that's also degree 2 in the second polynomial. I know that based off of the exponent, the largest exponent in each one. I also know that these are trinomials because they each have 1, 2, 3 terms. 1, 2, 3 terms. Okay, so we've got two quadratic trinomials added together. And when you add polynomials, they do not have to have the same number of terms. They also don't have to have the same degree. Because as you're going to see in a moment, all we have to do is go through and combine all of the like terms that are being added here. So I'm going to switch back my color to white to make this a little bit easier to see. And we're going to begin by first looking and seeing if there's anything outside of the parentheses for each of these polynomials that would tell us that we're not just adding one version of that polynomial or one copy, but maybe we're adding two of those polynomials, or maybe we're multiplying it by a negative number first and then combining them. But if I look right in front of the parentheses here and right in front of the parentheses here, I don't see anything that would tell me I need to distribute. So I'm just adding one of each of these polynomials. One 6a squared minus 4a plus 9 polynomial added to one other 2a squared plus 3a minus 5 polynomial. When that happens, that just means that the parentheses are only there to show you how the polynomials were originally grouped. When we add them together, we're going to combine all of our like terms. So in the first polynomial, I have a 6a squared term. I want to write that one down. And then I'm going to look and see what my next term is, negative 4a. That is not a like term with the 6a squared because it does not have the squared. Okay, it's just got an a. And then I have a positive 9 or a plus 9. That's a constant. That's not like the a squared or the a term, so it needs its own column as well. And I want to separate these with lines to just show which groups they belong to. Now I'm going to add the second one. 2a squared is a like term with 6a squared. 3a is a like term with negative 4a. And minus 5 or negative 5 is a like term with the constant 9. And now we combine our like terms. So 6a squared plus 2a squared makes 8a squared. I had 8 of those a squareds. I started with negative 4a, and when I added the second polynomial, that added an extra 3 to it. Notice we have a negative and a positive combining, and when you add negatives and positives together, they combine to cancel each other out, or at least part of them cancel out. Negative 4 added to positive 3 gives me negative 1a, or just negative a. Okay, I have more negatives than positives, so I should end up with a negative total. And then finally, 9 and a negative 5, that's like 9 minus 5. That combines to leave positive 4. So my answer in this first problem would be 8a squared minus 1a, or I can simplify that to just minus a, plus 4. So this is the sum of these original two polynomials. The sum means the result when we add them together. Let's go to a second example. Once again, we're adding two polynomials. This time I have a quadratic added to another quadratic, but notice the small difference here. Now, there is a coefficient in front of my first polynomial. That actually means I have three of those polynomials, and I'm adding it to one polynomial of x squared minus 2x plus 7. So before we actually add these together, one thing we can do to make this a little simpler on ourselves, instead of writing 2x squared and another 2x squared and another 2x squared to show that there were actually three of them, we can make this much simpler on ourselves by just figuring out how much those 2x squareds are worth if we distribute the 3. So if I multiply that 3 by each of these terms, 3 times 2x squared, that makes 6x squared. Then I have to just realize that I have 3 of the 4x's as well. 3 times 4x makes 12x. And I have 3 of the minus 5's. 3 times negative 5 is negative 15. So I can rewrite the original polynomial that has a coefficient of 3. I can just multiply that through and say that I want to have a total of 6x squared, then 12x, and then a negative 15. And then the second polynomial is exactly the same as it was. X squared, minus 2x plus 7. So if I group these terms, 6x squared, then I have, 12x, that's a different term. Then I have minus 15. My second polynomial, I have x squared. I have a minus 2x. That goes with the x terms. And then the constant goes with the minus 15 or negative 15 constant. Now we combine our like terms. 6x squared combined with another x squared. Remember that even though this doesn't have a coefficient, that counts as sort of an imaginary 1x squared, all right, or an implied, imaginary is the wrong word, but an implied 1x squared. 6 and 1 makes a total of 7x squareds. Then I have 12x take away 2x. That's going to make 10x. And negative 15 with a plus 7. Again, we're combining a negative with a positive, so some of them are going to cancel each other out. So we just subtract to see how many are left. Do the bigger number minus the smaller number, just based off of the magnitude, how big the numbers without the signs look. So the 15 take away 7 makes 8. But because the 15 was negative, this is actually a negative 8. Okay. So our total for this one, I'm going to write it on the left-hand side this time, 7x squared plus 10x minus 8. All right, so now we've gone through and we've added two polynomials. Next up, we're going to see what it looks like when we subtract two polynomials. Moving to our subtraction problems, first one we come across, now we have a cubic polynomial because we have a degree 3 for the first one and for the second one. So a cubic minus another cubic. Each of them has 4 terms, so we would just call these 4-term polynomials. But when we do this, what we have to think about is that there is a subtraction sign in the middle. So what makes this different? Well, one way you can think about this is we are subtracting one of these polynomials and subtracting one of these second polynomials. That's like almost having a negative 1 in front of this polynomial right here. So how can we go about this? Well, one thing we can do is distribute that negative 1 to each of these 4 terms. So we can multiply them, because if I subtract a 2x to the third power, that's like a negative 2x cubed that's going to be combined with the 5x cubed from the first one. And if I subtract a negative, subtracting negatives is like actually adding, because a negative times a negative makes a positive. So negative 1 times negative 3 would become positive 3x squared. Negative 1 times positive 5x makes minus or negative 5x. And negative 1 times negative 4 makes positive 4. So you'll notice that all the signs in the second polynomial have changed. The positive 2x cubed became negative. The minus 3x squared became plus. The plus 5x became minus. And the minus 4 became plus 4. So now, once we have done that, we've distributed the negative 1 and basically changed each sign in the second polynomial. Now we treat it just like an addition problem. We just combine these. So now I have 5x cubed, 4x squared, negative 3x, and positive 8 combined with negative 2x cubed, positive 3x squared, positive 5x, and minus 4, grouping each one with their like terms. And then we combine our like terms. If I have 5x cubed and take away 2, that leaves 3x cubed. 4x squared combined with 3x squared makes 7x squared. Negative 3 and positive 5, that's like subtracting 5 minus 3, that leaves 2x that are positive. And then 8 take away 4 leaves 4. So 3x cubed plus 7x squared plus 2x plus 4. This would be our result, and we would call this the difference between the original two polynomials. The word difference means that we are subtracting the two to see what the difference is, the value in between each one. Okay, so the difference between the original polynomials was 3x cubed plus 7x squared plus 2x plus 4. Let's see one more of these. 7a squared minus 3a plus 12 minus 4a squared plus a minus 6. So just as we did before, I'm going to think of this minus in between. It means that I'm subtracting one of these. So if I distribute that negative 1, then the second expression becomes negative 1 times 4a squared makes negative 4a squared. Plus a turns into minus 1a, or just minus a. And then the minus 6, I can think of that as a negative 6 being multiplied by negative 1. That turns it into positive 6. So now I'm going to list out my terms. 7a squared minus 3a and positive 12, all from that first polynomial. And now the second polynomial, once I have distributed the negative, I have negative 4a squared minus another a and a positive 6 constant. Combine my like terms. I get 7 minus 4 makes 3a squared. Once again, we keep the exponent exactly the same. We're just changing how many of those we have. Negative 3 minus another one. This is actually going to get even more negative because all of these are negatives. If you combine negative 3 and negative 1, that makes a total of negative 4a's. And then finally, we have 12 and 6 as our constants. Add those together and we get 18. So 3a squared minus 4a plus 18 would be the difference between the original polynomials here. So let's summarize what we just did in adding and subtracting. In both cases, we first check to see if there is a coefficient that needs to be distributed. We saw that, if I scroll back up for a second, we saw that in the second addition problem, we had to distribute that 3 because it told us we had 3 of those polynomials. And so we just multiplied each term in the original by 3. And then in the subtraction problems, that looks like multiplying each of the second polynomial's terms by a negative 1 or by whatever other value is in front. If you ever see a minus 2 and then the parentheses, then you're just distributing a negative 2 instead of just a negative 1. But we always check to see if a coefficient needs to be distributed. Then, as we just said here, that subtraction problem is just like distributing a negative coefficient. If you don't see a number in front and just a minus, you can think of it as distributing negative 1. And then finally, you combine your like terms using the columns to organize the information and then write out the final expression. So that kind of summarizes the basic idea behind adding and subtracting polynomials and their similarities. So now let's move into the last part, last key question for the day. How do we apply these concepts of adding and subtracting, trying to identify times where maybe we need to add or maybe we need to subtract? We're going to start with this application problem here. It says a rectangular garden has a length and width expressed as polynomials in terms of x. The length of the garden is given by the polynomial 3x squared plus 5x minus 2 meters, and the width of the garden is 2x squared minus x plus 4 meters. Our job is to write a polynomial expression for the perimeter of the garden, and then they give us the hint by first adding the length and width and then multiplying by 2. So what we're going to do is we're going to show our work on this one. I'm going to ask you in your notes to draw a picture of this rectangle. So let's show this rectangular garden. And we have a length on one side of 3x squared plus 5x minus 2, and then a width on the side of 2x squared minus x plus 4. And we're asked to find the perimeter of this. So we could go through and potentially label all four sides, right? The bottom and the top would have the same expression, and then the left and the right would also have the same expression, because that's how rectangles work, right? Opposite sides are congruent. So we could add all four of these together, or we could realize, wait a minute, if I take the one on the top, the length and the width, and I just add these two together, I could double that, and that would also take care of the bottom and the left. So instead of adding four expressions, we're just going to add these two, and then we can just double it, okay? So I'm going to make a little bit of space here on the left side. And I'm going to add these together. So I have a 3x squared, a 5x, and a minus 2. And I'm adding that to 2x squared, a minus x, and a plus 4. So when I combine my like terms, I have 5x squared. 5x take away an x, that means take away 1x. That makes 4x total. And then negative 2 plus 4, that's like 4 take away 2. That's positive 2. So I end up with 5x squared plus 4x plus 2 for one length and one width. So now if I double that, if I double each term and multiply it by 2, that would give me the total perimeter. So if I take all of this times 2, I'm going to end up with 10x squareds. 4x times 2 becomes 8x, and 2 times 2 becomes 4. So 10x squared plus 8x plus 4 would be the perimeter of this shape. All right. So this is how we can go about finding a sum of polynomials or adding polynomials together in a problem where there's a little bit of a story. All right. So now, just to recap, the topics we covered today: how do we add polynomials? We saw that we look to distribute if there's any numbers in front of the polynomials, any coefficients, and then we just combine our like terms. How do we subtract them? Well, it's almost the same thing as adding. We just have a negative coefficient in front of the second one, so we end up sort of seeing the signs change throughout the second polynomial, and then once again we combine like terms. And then we also saw how to apply these ideas in a contextual problem. So for the show me what you got, the sort of challenge problems here, to earn your bonus points on your note sheet or on a separate piece of paper, for problem 1, if you can try to create two polynomial operation problems, then solve them. So create a polynomial addition problem where you add a quadratic trinomial to a cubic trinomial. And then for the second problem, I want you to subtract a quartic trinomial from a cubic binomial. And you can use whatever coefficients you want, but see if you can make that problem. Again, a little bit of a challenge, but try it out. And then for problem 2, imagine a fence around an L-shaped yard. So a yard that looks something like this, maybe. You're asked to draw the fence around the property line on your paper, and then label each side with either a binomial or trinomial expression, and then find the perimeter of the fence. Okay, so second challenge problem there for you. Show me what you got with that one, and then good luck as you work on completing your notes.